Have you ever wondered how surgical instruments are made safe for use? Well, the answer lies in a process we call sterilization. It's more than just a quick scrub in soapy water. Sterilization is a meticulous procedure that ensures every instrument you come across in a medical setting is as clean as a whistle. This process is of paramount importance in the medical field. Imagine undergoing a procedure with tools that aren't properly sterilized. The risks are enormous, ranging from infections to serious complications. So, sterilization is not just about cleanliness, but also about patient safety. And how is sterilization achieved, you ask? Well, there are several methods, each with its own unique approach and application. From the scorching heat of an oven, to the invisible rays of radiation, to the tiny filters that sift out microorganisms, the methods of sterilization are as diverse as they are crucial. Let's delve into them. Imagine baking a cake in an oven. Now apply that concept to sterilization. We're talking about dry heat sterilization, a method that uses high temperatures to destroy microorganisms and ensure a sterile environment. Dry heat sterilization works by denaturing proteins within microbial cells, essentially cooking them to a point where they can no longer function or reproduce. It's like when you bake a cake and the heat transforms the batter into a fluffy delight. Except in this case, we're not making anything delightful. We're killing off harmful germs. The process involves placing objects in a sterilizer, often an oven-like device, and exposing them to temperatures usually between 340 degrees to 375 degrees Fahrenheit. The duration varies depending on the object, but it's typically between 1 to 2 hours. One key advantage of dry heat is that it can penetrate materials that steam can't. It's excellent for sterilizing glassware, oils, and powder substances. Plus, it doesn't corrode metals and is less harmful to the environment than other methods. However, it's not without its drawbacks. The high temperatures can damage some materials. Plus, the long exposure times can be inconvenient. It's also worth noting that dry heat isn't as effective in killing microorganisms as moist heat. They're like those stubborn cake bits that refuse to bake properly, no matter how long you leave them in the oven. There are two types of dry heat sterilization: static air and forced air. Static air, also known as oven type, is a slower process but is great for sterilizing large loads. Forced air, also known as rapid heat transfer, is faster and more efficient, but is best for smaller loads. Dry heat sterilization is a bit like baking. It requires the right temperature, the right time, and a little patience. Yet it's a vital tool in our fight against infection and disease. While effective, dry heat isn't the only method in our sterilization arsenal. If dry heat is baking, then moist heat is more like steaming vegetables. So, let's dive into the world of moist heat sterilization. This technique is all about using water to generate steam. It's like using a pressure cooker to prepare your favorite stew. The process involves high-pressure steam at temperatures above boiling point, typically between 121 to 132 degrees Celsius. Moist heat sterilization works by coagulating and denaturing proteins within microorganisms. This is quite similar to how an egg white changes from a clear liquid to a white solid when boiled. The heat affects the microorganism's proteins, causing them to lose their function, and thus leading to the death of these critters. One of the key advantages of moist heat sterilization is its efficiency. It is faster and more effective at lower temperatures compared to dry heat. This is because water is a better conductor of heat than air. Moreover, the process is non-toxic and leaves no residue, making it ideal for sterilizing a variety of tools and materials. But just as every rose has its thorns, moist heat sterilization does have some limitations. It can't be used for materials that are sensitive to moisture or high temperatures. Think of materials like powders, certain types of plastics, and oils. These would be damaged or altered by the process. Now you might be wondering what kind of instruments are typically sterilized using moist heat. Well, in the medical field, it's commonly used for surgical instruments, textiles, and other heat-resistant materials. Also, in the laboratory setting, it's often used for sterilizing liquids, media, and waste. In conclusion, moist heat sterilization is a bit like cooking. It's all about using the right temperature and pressure to make sure everything is properly cooked and free from harmful microorganisms. Just remember, it's not suitable for everything. Some materials are just too sensitive to handle the heat. Moist heat sterilization is a common method, but there are other methods which are just as important. Venturing into the realm of the invisible, we find gaseous and radiation methods of sterilization. Both are fascinating in their own right, painting a picture of how far we've come in our quest to eliminate harmful microorganisms. Starting with gaseous sterilization, this method uses lethal gases to kill bacteria, viruses, and fungi. The most commonly used gas is ethylene oxide, known for its high penetration and broad-spectrum efficiency. It's perfect for materials that can't withstand heat or moisture, such as plastic and electronic devices. But it's not all roses. The gas is highly flammable, toxic, and can leave residues, so it must be handled with utmost care. Now let's delve into the world of radiation sterilization, a method that uses ionizing radiation to destroy microorganisms. This can be gamma rays, electron beams, or X-rays. The radiation causes damage to the nucleic acids in the cells, preventing them from reproducing or functioning correctly. The advantage of radiation sterilization is its ability to penetrate packaging and product, meaning items can be sterilized in their final sealed pack, reducing the risk of recontamination. It's also swift, with materials typically sterilized in just a few minutes. However, it's not suitable for all materials. Things like plastics can become brittle, and certain pharmaceuticals may be adversely affected. On top of that, the setup for radiation sterilization is pricey, and it requires special facilities to ensure safety. But when it comes to high-volume production, think medical supplies on a grand scale, the cost and complexity can be justified. So whether it's gaseous or radiation sterilization, each method has its strengths and weaknesses. They're chosen based on the material to be sterilized, the level of sterility required, and the resources at hand. They're not your everyday household sterilization methods, but in the right environment, they play a pivotal role in keeping us safe from harmful bacteria and viruses. These methods may seem out of a sci-fi movie, but they are very real and very crucial. Last but not least, we have filtration sterilization. This is a method that's quite distinct from the rest, as it doesn't rely on heat, gas, or radiation to eliminate microorganisms. Instead, filtration sterilization uses a physical barrier to remove bacteria, viruses, and other harmful particles from liquids or gases. Picture this: you're pouring a cup of tea and use a strainer to keep out the loose leaves. Filtration sterilization functions in a similar way, but on a much smaller microscopic scale. Tiny pores in the filter allow the fluid to pass through, but trap any microorganisms, preventing them from contaminating the end product. This method has some clear benefits. For one, it's incredibly useful for sterilizing heat-sensitive materials, like certain pharmaceuticals, vaccines, or lab samples. Filtration can also remove particles too small for other methods to catch, like viruses or mycoplasma. However, it's not without its drawbacks. The process can be time-consuming, and filters can become clogged, slowing down or even halting the process. Furthermore, it's not suitable for all substances. Solid materials, for instance, can't be sterilized using this process. Despite these limitations, filtration sterilization plays a critical role in various fields, from healthcare to food and beverage production. It's a testament to the versatility of sterilization techniques, each with its own strengths and weaknesses, tailored to different needs. Filtration sterilization is a unique method, highlighting the diversity of sterilization techniques. So next time you're enjoying a clear cup of tea, you'll appreciate the science that's gone into keeping it free from unwanted particles. From baking-like heat to invisible gases and radiation, sterilization techniques are as varied as they are vital. We've embarked on a fascinating journey exploring the different methods of sterilization, each with its unique attributes and applications. We started with dry heat sterilization, reminiscent of a cozy kitchen oven, but with the critical mission of eliminating bacteria, viruses, and other potentially harmful organisms. We learned that it's not just about the heat, but the duration, with the process requiring longer times at lower temperatures. Then, we dove into the steamy world of moist heat sterilization, where we saw how pressurized steam can be a powerful adversary against microbes. We highlighted the importance of temperature and pressure in ensuring the effectiveness of this method. Our exploration continued with gaseous sterilization, where we discovered the role of ethylene oxide in sterilizing heat-sensitive materials. We also touched on radiation sterilization, revealing how ionizing radiation can eliminate microorganisms without the need for heat or moisture. Finally, we ventured into filtration sterilization, a method that physically removes microorganisms rather than killing them. We emphasized its unique ability to sterilize heat-sensitive liquids and gases, providing a crucial tool in the medical field. Sterilization in the medical field is not just about cleaning, it's about saving lives. Each method we've discussed today plays a key role in ensuring safety and preventing infections. So let's continue our exploration of these incredible topics. Subscribe for more because you won't find me later.